Okay, so I'm going to look at Josh 13, which is on logarithms and exponentials. So we start with question 1. Question 1, solve each of the following equations. A, solve 3x is equal to 27. Of course, here you're solving for x. So what you do is, using the basic knowledge that we have, we raise 27 to some power. So we write it in the form of 3 as a base, and then we look for the power. So these two can be equal if and only if x is equal to 3. Okay? If you are to use the properties of logarithms and exponentials, what we'll do is we'll do the same first, and then we'll apply log. So I can apply log 3x, and also apply log 3, 3. So I've chosen the base specifically to be equal to the base that I have on the right hand side so that I can find the value of x. Now log has the property of dropping the power, and so this becomes 3 log 3. Now one of the properties of logarithm is that if this one is equal to this, then we get a 1. So the 1 here, 3, a 1 there. So this gives us x is equal to 3. Now we must reuse this in times when we are unable to have this relationship here. Okay, if you are able, you can use that relationship and then equate the powers, just the same way we do when you're dealing with binomials. When dealing with binomial, you're told to find a term independent of x. So you get the powers of x. Maybe x is equal to 2r minus 4, and then you equate this to x power 0, and equate 2r minus 4 to 0. So you can use this principle here for as long as you're able to have those powers in that order where the base is the same. Okay, so we now go to B. B is half to the power x is equal to 1 over 16. Well, this can be written as 2 to the power negative 1 power x is equal to 16 to the power negative 1. So that we have 2 to the power negative x. You can also raise 16 to some powers. So you say 16 is 2. You're using this same base. So 2 to the power 4 to the power negative 1. And this becomes 2 to the power negative 4, implying that negative x is equal to negative 4. So x is equal to 4. You can do that. Alternatively, when you reach here, you can as well apply log. So you say log base 2 neg x is equal to log base 2 neg 4. Then you drop the powers, negative x log 2 is equal to negative 4 log 2, so that you get x is equal to 4. If you want, you can go the negatives and then divide. So x is equal to 4. It's the same strategy there. We go to C. C is 27 to the power 4x is equal to 9x plus 1. Okay, 9x plus 1. This is we can write this guy 27 as powers of, we can raise 9 to some powers to form 27. For example, if I said 9 to the power 3, mean 9 to the power, so for 9 we can't, because of 27 is too small for 9. So we raise 3. So we say 3 to the power 3 and then 4x. This is going to be, so also raise this 9 to the power as powers of 3, x plus 1. What does this become? 3 to the power 12x is equal to 3 2x plus 2. And I expand there. So this means that we have 12x is equal to 2x plus 2. This is the same as having 10x is equal to 2, so that x is 1 over 5. And so d is 1 over 8 to the power negative 2t, which is equal to 2t plus 3. Okay, I need to try this one so that you see if you've understood these first 3 questions. So just try, you know what to do here. So you take 8 up and then express it in terms of 2, and then be able to get the powers. Got question 2. Question 2, you're looking at sketches. Sketch the graph of a f of x is equal to 3 to the power x. The easiest way of sketching exponentials is by using a table. Just use a few numbers. So let this be x, let this be f of x. You can use numbers like -2, like 0, and then 2, where for me to find the corresponding value of f of x when x is 2, when x is -2, I substitute -2 here. So I have 3 to the power -2, and this is 1 over 3 squared, which is 1 over 9. So I have 1 over 9 there. Again, I have f of 0, which is 3 to the power 0, which is just 1. So I have 1, and then f2, this is 3 to the power 2, which is 9. So I have 9. So now I'm able to sketch. I put the graph here. So for x's, we have -2, we have 0, we have +2. And for the y's, we have 1 over 9, we have 1, we have 9. So what is important is that -2 is giving us this value, 0 is giving us 1, and the other one is giving us a value on top. So we'll be able to sketch the graph. We'll be able to sketch the graph. And that's how the exponential graph works. Now, when you sketch 3 to the power x, what you're saying is that you have sketched a to the power x, where a is a positive number. The next time they'll ask you to sketch the graph of f of x is equal to e to the power x. You just come and draw this very graph, because e to the power, if you had to use the same table, you say e to the power -2, it will give you 1 over e squared. E to the power 0, it will give you 1. E to the power 2, it will give you e squared. Because now this number is positive, these numbers will come and fit in 1 over 9, 1, and 9. We just change their values. and the graph will come out. So every time I see a positive base, I know my graph will come out like that for as long as the power is also positive. So let's go to B. B is f of x is equal to 1 over 4 to the power x. Now what we have seen in question A was a constant whole number. It was a whole number, positive whole number. Now here we have a fraction, meaning that we need to write our fraction in whole number form. So just temper the power, so it becomes like that. And this becomes 4 negative x. Our interest is to sketch, so we come up with a table and see what happens now when the whole number is positive and the power is negative. So we have negative 2, we have 0, we have 2. So f of negative 2 is equal to 4 of negative that is there already, and then the x that we're bringing is negative. So we'll have 4 squared, which is 16. So we put 16 here. F of 0, it will be 4 negative. The x coming is 0, but 0 does not care about the sign, so we get 1. Then f of 2, we have 4 negative for the x, but the x coming is positive. The negative remains there, but this is the same as 1 over 4 squared, which is 1 over 16. So we have 1 over 16. And so we are able to sketch. So we have negative 2, we have 0, we have 2. And we have 1 over 16, we have 1, we have 16. Now, when it's negative 2, we are getting positive 16. When it is 0, we have 1, and we have that. So sketching this will be like that. So this graph does not touch the x-axis for very simple reasons that there is no number that when we put as the square of x as the power of 4 will give us a 0. So meaning that we'll never have f of x to be 0. That's why we are showing that this graph is not touching. It will just go like that. So even here it's the same thing. It will just go like that. It won't touch. And then C, f of x is equal to 2x minus 1. Now 2x minus 1, well, again you can form a table. Say I'm forming a table x. I'll form the same table and see what happens. Except that this time around, after I put 0, I'll put 1 and then bring back the 2. Why am I putting 1? Because that is the one that is there. I want to see what happens when I subtract that number which is right there, when I put a very number to subtract from itself. And this is f of x. So you get f of negative 2 will get 2, negative 2 minus 1, which is 2, negative 3. And that is 1 over 2, 3, which is 1 over 8. So I have 1 over 8. F of 0, it will be 2, 0 minus 1, which is 2 minus 1, which is half. Now this point is very important because it is there, y-intercept, so you cannot skip the 0. Then f of 1 now you get to 1 minus 1, which is 2, 0, which is 1. And then f of 2, we have 2, 2 minus 1, which is 2, 1, which is 2. And so we now sketch our graph. So this time around, we have negative 2 here, we have 0, we have 1, and we have 2. So at 0, it's no longer crossing at 1 now. This time around, and we have 1 over 8, we have 1 over 2, and we have 1, and then we have 2. So when it's 1 over 8, so when it's negative half, we're getting 1 over 8. When it's 0, we're getting half. When it's 1, we're getting 1. And when it's 2, we're getting 2. So the graph, the shape has the same orientation. Okay. But one thing to note is that this graph, the first initial graph, this one, crossed at 1. But this time around, it has been moved by 1 step to the right. So it's like a phase shift when you're dealing with trigonometry. So you're shifting it to the right. If you don't understand how to shift without having a table, you better use a table and just make sure that that number, which is the shift magnitude, you also put it on the table. So it will tell you how far your shift is. Okay. So from there, we sketch also D. So we sketch D, f of x is equal to 2 negative modulus of x. Now the easiest way of sketching, I have said, is just to pick numbers. F of x, so pick negative 2, pick 0, pick 2. To be able to tell you the shape. What you're looking for here is a shape and the orientation of that shape. So f of negative 2, that is 2, negative is right there. Where are you taking your x? You're taking your x in the modulus. What does the modulus do to the negatives? It makes them positive. So that number remains as a positive there. But there's a negative outside which is not in the modulus, which does not get tempered with anything. So when you take the negative 2, it will go inside the modulus. So when it goes inside the modulus will make it a positive number. It will come out as a positive, then it will find the negative. So you have 1 over 2 to the power 2, which is 1 over 4. So we have 1 over 4. F of 0 to negative. Take 0 in the modulus. 0 is neutral, so the modulus does nothing to it. But when 0 comes out, it finds a negative, except that the negative also does nothing to it. So it just remains that, which gives us 1. What about f of 2? This will be 2 negative modulus of 2. It's positive, so nothing happens there. We just remain with that, which is 1 over 2, 2, which is 1 over 4. So again, 1 over 4. Wow, a very interesting graph. So we sketch it. So we have negative 2, we have 2, we have 0. 0 against 1. Negative 2 against 1 over 4. Here, 2, 1 over 4. So our graph will spread like that all the way into 1 and get down to the other side. Because it's using the same, it has got the same numbers after the 0 on the right. If you want, you could try 3 and negative 3. they will still give you the same numbers. So it will make that shape. Okay. So that is how you graph exponentials. Then now we go to question 3. Question 3, a bit of some simple applications of exponentials. So suppose that in a certain bacterial culture, the equation, so this is coming from question from tutorial sheet 13, question 3. So we're saying, suppose that in a certain bacterial culture, the equation this is equal to 1000 E 0.4T. Expresses the number of bacteria present as a function of time T, where T is expressed in hours. The first part is how many bacteria are present at the end of 2 hours. This expression is giving us the number of bacteria present per T hours. Now, how many at the end of 2 hours? So T is 2. So we are looking for the value of this number, 2. This is 1000 E 0.8. And so I can leave it there because in this course, don't use calculators. So I leave it there, the first part. The second part is how many at the end of 3 hours. So I put a 3 there, 1000 E 0.4 by 3. This becomes 1000 E 1.2. I leave it there. Okay, so we put it here, question 3. What about for the percent hours? Okay, so that one is just waiting. Whenever you are told what percentage, then you calculate the value of hours and then substitute. They will substitute for 2 and for that. Then we go to question 4. Suppose that a certain substance has a half-life of 20 years. If there are present 25 milligrams of the substance, then the equation, another equation, this is that 2 negative T over 20. Okay, the twin down there is the half-life. The 2500 that is there is if there are present 2500 milligrams of the substance. So this is the first number that is there. Okay, then the equation is that you put the amount remaining after T years. How much remains after 40 years? This study is done on 2500 milligrams of substance that is to be studied. And these substances move every after T years, okay, with a half-life of 20. Now the question is, how much remains after 40 years, after T years? So you go and substitute whether it is your T and have 2 negative 40 over 20. So this becomes 2500 2 to the power negative 2, okay, which is over 2 to the power negative 2 is just 1 over 2, which is 4. And so you're able to divide here and get some values. So you say 4 into 25, it goes 6 times remainder 1. 4 into 10, it goes 2 times remainder 2. And 4 into 20, it goes 5 times. So this is the number that will be remaining after T years. Okay. What about after 50%? 50% years. So you could take this 50% years as 50% of the half-life. The half-life is 20, so 50% of it would be 10. And so you substitute 10 while there is your Q. Or else some more guidance was needed on the 50%. Okay, so we go to question 5. Question 5, write each of the following in algorithmic form. For example, if you are given 2 to the power 4 is equal to 16, this will become, in logarithmic form, this is going to become log. This number which is here, the base, goes as the base. The number on the right, this 16, sits here. It must be equal to 4. So if you are given this in exponential form, to write it as a logarithm, you write it in the form on the right. Now, your A is write 10 to the power 1 is equal to 10 in logarithm form. So you say log, this number which is here, 10, this number which is on the right, there, is equal to 1. So here you are picking properties. We are picking properties of logarithms. Okay, and also seeing the equivalence with exponentials. So this is telling us that the next time we find log a, we'll have 1. And in exponential form, it will be a1 is equal to a, which is true. Okay. 2, let's go to b. b 2 over 3 to the power negative 3 is equal to 27 over 8. Write it in logarithmic form. Okay, nothing changes here. You have the log. This number sitting here is 2 over 3. And then you bring the number on the right, 27 over 8. This must be equal to negative 3. Now, sometimes you can be asked to show that, to find this value. Okay, so maybe they ask you to show that this value is equal to negative 3. So we have answered the question already. But what if you were asked to show that this number is equal to negative 3? What do you do? Okay, so we also have a property that says if I have a x to the power b, this will be the same as b log a x. So the log is able to drop the power. First thing. Second thing, so the third thing again is I'm able to change the base from a to b by taking b there, dividing by this. This is the conversion that we use in changing the base. Okay, now I want to show. So you pick this number, 2 over 3. 27 over 8 can be written as what? As 3 over 2 to the power 3. Okay, now here we have 2 over 3. So if we can switch things inside there, we keep the 2 over 3. Then we go inside there and say, okay, we now want to write this expression as what? As 1 over 2 over 1 over 3 to the power 3. I mean, it's the same thing. If you have to solve those, it will be 1 over 2 over 1 over 3, which is the same as 1 over 2 multiplied by 3 over 1, which is 3 over 2, which is what we have there. Now I've written them as fractions. So when I have a fraction inside, it's just the same as 2 over 3 as my base, and then 1 over 2 it can be written as 2 to the power negative 1, 1 over 3, 3 to the power negative 1. So I'll have this to the power 3, which is the same as log 2 over 3, and the negative I can take them outside, so I have 2 over 3, the negative 1 multiply with 3, so I have negative 3. But the log has the power to drop the power. It has that property, okay? And when this is the same as that, we are getting back to 1 AA. So here we're just getting negative 3 multiplied by 1, which is negative 3. So you're also able to show in case they ask you to show or to find the value of that. That's what you do. Okay. Then we have C, write 10 to the power negative 2 is equal to 0.01. How do you write 0.01? Then that you do, we just start to express as logarithm. So just say, okay, this will be log 10 0.01 giving me negative 2. You're done. D 10 5 is equal to 100,000. As a log, I'll say log base 10 of 100,000 will give me 5, which is true. Okay, then now we go to question 6. So there are some more properties that I could have listed there. If we list all the properties of logarithms, we have, if I have the base 10, I can as well just write it as log x, because 10 is the standard base. If I have log ex, I can as well just write it as ln x. We do that. Then, if I have log ax plus log ay, this is the same as log a x multiplied by y. And if I have log ax minus log ay, this is the same as log a x over y. So I can do all such things. Okay, you've seen the power dropping, the sum being the product, the difference being the quotient. So we move to question 6. Question 6. Write each of the following in exponential form, with an example given that if you have log 2, 8 is equal to 3, the exponential form of this will be 2 to the power 3 is equal to 8. So to get this 2 to the power 3, you must get 8. So let's go and see. A is log 2, 64 is equal to 6. Exponential form 2 to the power 6 is equal to 64. So saying 2 to the power 6 is equal to 64. B log 10 0.0000, how many zeros? 241 is equal to negative 5. This will imply that we have 10 to the negative 5 as a power is equal to 0.1234. C log 2 1 over 16 is equal to negative 4. In exponential form, 2 to the power negative 4 is equal to that. So I have 2 to the power negative 4 is equal to 1 over 16. So our job was just write in exponential form and not do anything else. So that's how we write them in exponential form. Okay, now we start looking at how to solve equations. That is question 7. So I'll do it from another page. Yes. Question 7. A. Solve each of the following equations. 2 to the power 2x plus 3 2 to the power x minus 4 is equal to 0. So we have 2 to the power, remember, if I have a to the power mn, I can write it as am to the power n, or as an to the power m. So here we have 2 to the power 2x. We can write it as 2x to the power 2 plus 3 2x minus 4 is equal to 0. You should never multiply this 3 by the 2x and have 6 to the power x. No, no, no. It doesn't work like that. So from there now, you say, okay, this is almost a quadratic, but am I able to see it clearly? If I can't, I'll let p to be 2 to the power x, and then come down here and have p squared plus 3p minus 4 is 0, which makes sense now, and it's a quadratic. The product is -4, the sum is 3. So I can easily break this sum into -p plus 4p minus 4 is 0. And so I'll have p minus 1 plus 4 p minus 1 is 0, which becomes p minus 1 p plus 4 is equal to 0. So p is 1 or p is -4. Now, I get back to my p. My p is 2 to the power x. So it will be 1 or 2 to the power x. It will be -4. Now, I don't have a number, but when I bring as the power of x, I'll get a negative value. So I discard this. Okay? And so I remain with 2 to the power x is equal to 1. Now, if I don't know anything here, then I'll bring the power. I'll bring the log base 2, 2x, which will be equal to log base 2, 1. And then x will come down, and log 2, 2 will remain with log 2, 1. But log 2, 2, coming from the properties here, log AA is 1. And so we can just add just here another property that log A1 is going to give us 0. Because in exponential form, this will be A0 is equal to 1, which is true. So when you come back here, we have log 2, 2 giving us 1, and log 2, 1, because there's a 1 inside there, giving us 0, which makes sense because if we had 2 to the power 0 here, then of course we'd get 1. So that becomes the value of x. If you want, you can take that to test. It must make sense. Okay. So the other one we discard, and because we never have such a thing. Then b, we go to 3 to the power 2x plus 1 minus 26, 3x minus 9 is equal to 0. Now, this becomes 3 to the power 2x multiplied by 3 to the power 1 minus 26, 3 to the power x minus 9 is 0. Our target here is to make sure that the 3 to the power x is be I mean standalone everywhere where we see it. So we're trying to extract it from the first number here. So because we had powers adding, we could multiply the same 3 with those powers. Now the same thing here, this 3, x will remain inside, and the 2 will go outside. We're still multiplying that, minus 26, 3x minus 9 is 0. From there, this is just the 3 multiplied by 3x squared minus 26, and 3x minus 9 is 0. So again, we let y be equal to 3 to the power x. So what we have is 3y squared minus 26y minus 9 is equal to 0. You multiply 3 by 9, you get 27, negative 27. And the sum is negative 26. That's an easy thing to break. So you say 3y squared, you need a minus. First you start with the plus y, and then minus now, 27y minus 9 is 0. Yeah, it makes sense now. So, okay, so we have y here is common. So we have 3y plus 1, and we have 9 here is common, negative. So we have 3y plus 1 is 0. So we have y minus 9 and 3y plus 1 is equal to 0, giving us y is equal to 9 or y is equal to negative 1 over 3. Okay, so we go back here and say, okay, what do we have? We have our 3x as y, so it is 9, or our 3x as y, so it's equal to negative 1 over 3. Again, this does not happen. You cannot have a positive power or a negative power giving you a negative number on the right when the base is positive. So we discard. And then here, we can raise that number. We can raise this to base 3 to the power 3 and to the power 2 for us to get a 9. So x is going to be 2. Okay? And just there, it will make sense. Then we go to C. C has 4 to the power x minus 6, 2x minus 16 is equal to 0. So here, I'll just give you guidance. You should be able to finish this. We try and see if you have understood A and B. Because we have 2 to the power x there, what do you need? You need to have 2 from the 4 to the power 2. You know this is 4, and then x outside. Minus 6, 2x minus 16 is 0. What next? I mean, you can switch the powers. X can go inside, 2 can go outside, and then you have 6. 2x minus 16 is equal to 0. So at this point now, you should be able to finish up. So finish this. You see if you have understood A and B. Okay, and then we have the discussion. If you don't understand, you start from there to ask. So we go to question 8. Question 8, solve each of the following equations. A log 5x is equal to 2. Meaning you're looking for x. So what do? You straight away find x by expressing this in exponential form. So x is 25. That's all. You get log 4 m is equal to is equal to 3 over 2. So what you do? Say, okay, 4 to the power 3 over 2 is going to be m. Are you able to express this further? Yeah, m is going to be the square root of 4 to the power 3. The square root of 4 is 2 to the power 3, so you get 8. Like that. And c is log b3 is equal to half. So you're saying b half is equal to 3. Wow. You want to get b. So what do? You square. Square, square. So b is equal to 3 squared, which is equal to 9. That's how you solve this one. We got to question 9. Question 9, express the following as a simple logarithm. For example, you're given 3 log b x3 over y2. So you express it as a simple logarithm. So you say this is the same as, first thing, this is the same as log b x9 minus log b x6. You must first know how this example is gotten. Okay, so what happened here is the power, this 3 here, went back as a power, so that it became log b x3 over y squared to the power 3. Okay, then these powers now multiplied. So x 3 by 3 9 over y 2 by 3 6. And remember the properties, I gave the properties here, that if you are subtracting, you can write it as a quotient. Now if it comes as a quotient, you can write it as a difference. That's where now it's coming in to say this is just the same as log b x9 minus log b y6, like that. So the next step, we now go to a. Okay, we express. So a, we have 2 log bx plus 4 log by minus 3 log bz. So to express this as a simple logarithm, you take back the powers, so it will become log bx squared plus log by4 minus log bz3. And then where they are adding, log x squared plus log y4, it becomes a product of the same base. So x squared y4. And then the minus 1 comes down to divide. So this is how you express as a simple logarithm. Okay, we go to b. b 2 log bx plus half log bx minus 1 and minus 4 log b 2x plus 5. This is equal to log b x squared plus log b square root of x minus 1. It's the same as power half. minus log b 4. Then you write this as a single log. So you say log b, the sum, you get the product s squared multiplied by x minus 1. The difference, you divide by 2x plus 5 to the power 4. You do that. Then c, okay, so c half log bx minus 3 log bx plus 4 log by. Okay, so you have seen what we did in a and b. So try and do c. Okay, don't understand, you let me know. Just WhatsApp me, I'll be able to respond. But I'm hoping that you should be able to understand. So you go to question 10. So question 10, solve each of the following equations. A log 10 5 plus log 10x is equal to 1. The first thing here is this is 10, that is 10. So you put these things together. 10 5x is equal to 1. When it's a sum, you multiply and then take to exponential. So you have 10 to the power 1 is equal to 5x. This is the same as 10 is equal to 5x. Divide by 5, divide by 5. So you get x is equal to 2. B, again log 10 x plus log 10 x minus 3 is equal to 1. So same thing, you get log 10 x minus 3 is equal to 1. Then this becomes 10 power 1, which is equal to x squared minus 3x. I've expanded there inside. So we get x squared minus 3x minus 10 is equal to 0, which is a quadratic. And then what is the product here is negative 10. The sum is negative 3, so you can use negative 5 and positive 2. So we have x squared plus 2x minus 5x minus 10 is 0, so that we get x plus 2 minus 5, x plus 2 is 0. So you get x is equal to negative 2 or x is equal to 5. Okay. Now when x is equal to 5, you go back and test in the original question. So when you bring 5 here, you bring 5 here. Would it make sense? So let's try the testing now. It's very important. So the testing, x5, that will be log 10 5 plus log 10 5 minus 3 2 is equal to 1. This becomes log 10 2 by 5, that is 10 is equal to 1, which is true. What about negative 2? When you take log 10 negative 2, this is undefined. Negative 2 again to be negative 2 minus 3, undefined. It only works when you multiply, but in the original case, it doesn't work. And so x is equal to 5 is the only solution. And then you look at C. C is log 10 x minus 4 plus log 10 x minus 1 is equal to 1. So this again is log 10 x minus 4 x minus 1 is equal to 1, which is log 10. Now you change it to exponential, so it becomes 10 to the power 1, which is 10, is equal to x minus 4 and x minus 1. So this is a quadratic that you get as x squared minus x minus 4x plus 4 is equal to 10. So you get x squared minus 5x minus 6 is equal to 0. When you bring 10 the other side, it will come as negative. Then this is x squared minus the product is negative 6. The sum is negative 5. So you use plus x minus 6x minus 6 is 0. So you have x plus 1. Here you pull out negative 6, remain with x plus 1 is equal to 0. So x is negative 1. Now x is 6. Now when x is negative 1, we face the same thing that we faced on the other one here. So we always discard this because it does not work in the original quotient. It makes it undefined. Then we have the positive when x is equal to 6, but not that every negative will want to work. Some negatives will work as long as you test them and they're defined. So in this case, they don't work because you're facing a negative in the log directly. Then x is equal to 6 will work. So even if you test, you have log 6 minus 4, that is 2, plus log 6 minus 1, that is 5, 10. If you multiply this to get 10, and so have log 10, 10, which is equal to 1. So it's true, x is equal to 6. Then d, you have log 10 x plus 2 minus log 10x is equal to 1. So here you get log 10 x plus 2 over x because of the minus is equal to 1. This is just 10 to the power 1 is x plus 2 over x. So you solve this, you cross multiply, you get 10x is equal to x plus 2. And so you have 9x is equal to 2. So x is 2 over 9. That's what you are looking for. Okay, so we go to question 11. Question 11, solve the simultaneous equations. A 2 log y is equal to log 2 plus log x. Simultaneously, 2y is equal to 4x. So you are solving these two simultaneously. So what you do is you first write this in exponential form. Okay, so this is in exponential form first. You get log y squared is equal to same base on the right. So you have log 2x. Okay, now the base is 10. The base is 10. That is clear. So same base and the two things are equal. This means that y squared is equal to 2x. So when we have that, we also have that from the other section here. We also have that 2 to the power y is equal to 4x. You're looking for y. So what do? If you apply log on the right, you get If you apply log 2, you get log 2 to y is equal to log 2. Therefore, 4 can be written as 2 to the power 2, and then x. So this gives us y log 2 is equal to, you can bring down the 2x and get log 2, that is 1, that is 1, so y is equal to 2x. This is giving us such a situation that y is equal to 2x. Okay, they are solving simultaneous. So you come here, where there is y, you substitute 2x squared is equal to 2x. So you get 4x squared minus 2x is equal to 0. So we find the value of x. So here we have solve it in any way. We factor out 2x, it remains 2x minus 1, which is 0. So x is 0, or x is equal to half. So what is y? Y is 0, or y is equal to 1. So I have found these values. Now you test. If x is 0, log 0 is undefined. So we rule it out. And there, because log 0 is undefined, but for x is equal to half, y is equal to 1. Of course, this guy, they make sense on the right? Yes. They make sense in this equation, but not in this equation. And then x is equal to half. If we test in the first one, we have 2. When x is half, we are getting y to be 1, which is a log 2 plus log x is half. So this is 2 log 1 is equal to log 2 multiplied by that. And so this is 2 log 1 is equal to log 1. So this is the same as log 1 squared, which is just 1, which is log 1. So x is equal to half, y is equal to 1. Satisfy the first equation. What about the second equation? 2 to the power 1. Is it the same as 4 to the power half? So this is 2 on the left. This is equal to 4. So we have 2 is equal to 2. So again, they satisfy both equations. So we discard the other set because it does not qualify. It does not mean well to the first equation. Oh, but we can still use it, because if we take x to be 0 in this equation, what we'll get is 2. Y must also be 0. So we'll have 0 here, and we'll have 2 there plus log 0 there, which is log 0 squared is log 2 multiplied by 0. Okay, and this is log 0, which is still log 0. So they are equal but undefined. So I suggest that we also put it here. X is 0, y is 0. That's another set of solution. So it's a point there satisfying the equation. Okay, so I go to B. B we have log 3x is equal to y, and the same y minus 1 like this. So this means that y is equal to log 3x And the same y is equal to log 9 to x minus 1. So the first one in exponential form, it is 3y is equal to x. The second one, it is 9y is equal to 2x minus 1. So we are solving these two equations simultaneously. Okay? So what we do on the first one there, on the first one there, you can apply, you can either choose to bring the x here. So you say, I have 9y minus 2x plus 1 is 0. This is 9y minus 2. What is x? X is 3 to the power y plus 1 is 0. But this is 9 to the power y. So I can express it as a base of 3, 3 squared. Then this 2 multiply the power y. So I have 2, 3y. This is minus plus 1 is 0, which is 3y squared minus 2. 3y plus 1 is 0. So again, you let p be 3y, so that you have p squared minus 2p plus 1 is 0. So 1 is a product, so negative 1, negative 1. We get that is 0. So p minus 1 minus p minus 1 is 0. So we have minus 1 outside for the other one. So we have minus 1, and then open up. So we have p minus 1, p minus 1 is 0. So p is equal to 1. So get back here and say 1 is equal to 3 to the power y, implying that if you apply log 3y is equal to log 3y, this will give us log 3.1 is equal to y log 3.3. Now 3.1 is 0, so we have 0 is equal to y. So y is 0. So when y is 0, what is x? We have x is equal to 3 to the power y. Now when y is 0, x is going to be 1. So we have 1 comma 0. In other words, we are saying x is 1 and y is 0. Okay, so I put a test there and it will make sense. 9 to the power 0 is equal to 2 minus 1, which is 1. So it makes sense as a solution set. Okay, so we go to question 12. Solve simultaneous equation. So it's just an extension of question 11. So you have log x plus y is equal to 0. You also have 2 log x is equal to log y plus 1. So simultaneously. When the base is not appearing there and we have log, I said it's the same as having base 10, so you can put it there. So this one, if you raise it to exponential form, it will be that, implying that x plus y is equal to 1. And then the other one, this becomes log 10 x squared minus log 10 y plus 1 is equal to 0, so that we get log 10 x squared over y plus 1 is equal to 0. So when we raise 10 to the power 0, we must be able to get this. This is x, y plus 1. So we are saying 1 is x squared, y plus 1. If we cross multiply, we have y plus 1 is equal to x squared, implying that y is equal to x squared minus 1. Now here also y is equal to 1 minus x. So this is y, this is y. So you can equate the two y's. 1 minus x is equal to x squared minus 1. Okay? So putting these the same side, we have x squared plus x minus 2 is equal to 0. Is it because we take this as a negative, we take this as a positive, and so you have a 0. So you have x squared plus x minus 2 is equal to 0. Do we have two numbers? When you multiply, you get that? Of course, yes. That would be x squared minus x plus 2x minus 2 is 0. So we have x minus 1 plus 2, x minus 1 is 0. So x is 1 or x is negative 2. Now, if x is 1, does it satisfy of what is y? When x is 1, we can use the simplest one here. Can use the simplest one here. We say, okay, when x is 1, when x is 1, y is 1 minus 1, which is 0. And when x is negative 2, y is 1 minus 2, which is 1 plus 2, which is 3. So this is negative 2, and then we're getting 3. Now we test. Does it make sense? Does it make sense in both equations? Let's see. If you bring here, when x is 1, we have y is equal to 1 squared minus 1, which is 0 again. When x is 2, we have 2 squared minus 1, which is 4 minus 1, which is 3. So it makes sense to exponential equations. What about the log equations? We go, when x is 1, y is 0. Of course, this is log 1, which is 0. So we tick x is 1, y is 0. This one, we have checked, comma, we check another one. We go, when x is negative 2, inside there, y is 3. So we have log 2 minus 3. This is equal to log, this is minus 2. So this is equal to log negative 2 plus 3 is just log 1, which is equal to 0. So for that one there, we have x is negative 2, y is 3. Just work there. Does it work on the right? On the right, it does, because when x is negative 2, we have 2 log negative 2. Before we say it is negative, we take back this power. So this part becomes log negative 2 squared, which is log 4. Okay? So we have log 4 is equal to a log, when y is 3, so I have 3 plus 1, which is equal to log 4. So again, this one is satisfied also. So we tick, so these are our solution sets. So I hope you enjoyed this, and please, if you have any questions, you are free to WhatsApp me, but we'll see our discussion on this, where you're able to ask questions. And don't forget to share with your friends, and always subscribe and take the notification sign. Thank you so much for watching. And for those who want the lessons, if you feel that you're very much behind, when you share to your friends, and just advise them to check on the link, so many videos that have been posted there. Thank you.